Assalamualaikum and very good morning to everyone. Okay, I am Hashimah ICAEE from the University Technology Mara, UiTM Shah Alam. So today I would like to present my research titled Development of Real-Time Monitoring System for Aquaculture Farming Using IoT. So these are all my co-authors for this research. So I'm going to start with the introduction. The aquaculture sector in Malaysia has continuously attracted interest among local people. Since the 1990s, the aquaculture sector have been growing at an annual rate of about 11%, surprising that of all other aquaculture commodities in the region. With this increasing growth, the freshwater fish breeding company developed rapidly after the involvement of various stakeholders from the private sector, government agency and individuals. Factors that promote freshwater fish farming are the significant potential market both inside and outside of the country. Fish farming may also increase income and improve local production of food and export earning. Many technologies used in aquaculture look very simple based on on-site innovations. For example, feeding methods, water temperature, water pH and dissolved oxygen in the water that has improved the growth and lifetime of the species. The problem with the current situation in the fish farm industry face is the challenge of labor shortage, mainly for operators to monitor their fish farms. At the same time, this industry has no awareness of their fish farm conditions such as the concentration of dissolved oxygen, pH value, temperature and water level. The real-time remote monitoring of aquaculture water quality had great practical significance in the reduction of labor intensity, improvement of the quality of aquatic products, and protection of the water environment. So next we proceed to the methodology of the research. So here from figure 1 here, it shows the block diagram of the project. Okay, in this project, we use microcontroller from Intel Edison. And then the cloud data, we use IBM Bloom Mix. And then end user, the user can access the data using the mobile phone. So figure 1 shows the block diagram of the project which is divided into 3 parts. The project is focused on the programming of the microcontroller to the end user here. It starts from the microcontroller. Then the microcontroller establishes a connection with Wi-Fi to upload the data to the cloud database. The data uploaded is stored in the cloud database and accessible by the user. Okay, next one, figure 2 shows the implementation of the Intel Edison. Here, the overall of the diagram. Figure 2 shows the hardware setup for the project where the Intel Edison is interfaced with the cloud via Wi-Fi. When Intel Edison is connected to the cloud, the data then is transmitted to the cloud. All the data in the cloud is accessible by the user through their personal computer or mobile phone. Okay, here figure 3 and figure 4. Figure 3 shows the flow of the data from the sensor here, and the figure 4 the actual data transmitted to the cloud. Figure 3 shows the flow of the data from the sensors. The data first is converted from the sensor reading to the data measurement on the Intel Edison. The data then is transmitted to the cloud IBM Bluemix by using JSON format. And then the data was stored in the database. Cloud then NoSQL-DB. For the user to monitor, to review the data will be fetched from the database and it will be displayed on the user personal computer or mobile apps. Based on figure 4 here, the set of data transmitted to the cloud in the JSON format contains the ID and the reference of the package which has been generated by IBM Bluemix. The packet also contains the data from the microcontroller which contains the date, time and measurement. Here, next section, we go to the result and discussion. Since this research quite simple from the student research, so it's only display the data from the apps, okay? So here figure 5 shows the actual data of actual display of data on the IBM Bluemix, how it looks like. The data transmitted are displayed as shown in figure 5. Each measurement of the parameter is set in a range to make sure the data is shown in detail. The data display is shown is based on the data that is being uploaded to the cloud storage. And then figure here, it shows the actual display of the data on the mobile phone. The user is also able to check the fish pond water quality using the mobile phone as shown in figure 6 here. They can see the live data and the past data in the list and graph form. Okay, in the list, in terms of the list and the graph format. This makes it easy for the fish farm owner to monitor their fish pond at any time and anywhere. As the conclusion, the real-time monitoring system is the new solution to overcome the challenge faced by the fish farming industry. The implementation of the internet in the system, it made the owner of the fish farm more aware of their fish farm condition by checking the data that were collected by the input sensors. With the increasing demand for food sources, this project may give an impact on the number of food production from the aquaculture sector. IoT has distributed to lots of change in the nowadays world, and with the implementation of IoT in the project, it will become a good platform to technologize the fish farming industry. With all the data collected, it could be shared with researchers and other fish farmer owners where it can be used to improve the quality of fish production in the future. And nowadays, data will become the new standard platform for the upcoming fish farming industry. The project will impact the production of the fresh fish industry and hence will support the demanding numbers of food based on the aquaculture industry productions. The concept of IoT in this project has proved and it could be used in another sector. Okay, this is the acknowledgement of the project. It's supported by the internal grant of UITM. And with that, thank you. I end my presentation.